Again, I want to thank everyone for attending our What's in Your Pond seminar today. My name is Pat Depkin. I've been with MDE for about 5 years. 25 years prior to that, I spent in the private sector consulting industry. So I think I've got a pretty decent perspective on what goes on as far as post-construction and maintenance inspections on facilities. I can't cover it all in 30 minutes. We're going to hit the high points. We're going to look basically and focus on structural issues. But there's much more to talk about, and certainly we can entertain any discussion on that at a later time. So straight away, why are we doing these inspections? COMAR 26.17.0211 maintenance specifically says that any county and municipal ordinance shall provide for inspection and maintenance of stormwater facilities. Now, that doesn't mean the county or jurisdiction has to do the inspections. Depending on how their system is set up, you may do them yourself. You may have contractors to do them or consultants to do them for you. Excuse me. Or you may require the facility owner to hire a contractor or a consultant to do the inspection. But the important thing to remember is this shall provide for. So one way or another, these facilities within your jurisdictions are going to get inspected. So to kind of build on that, why are we doing these inspections? Well, as I just said, the law requires it. Your county and municipality shall provide for inspection and maintenance of stormwater facilities. There's many ways to get that done, as I mentioned. Safety. Poorly maintained detention or retention facilities are a hazard to life and property. We don't want these embankments to fail and cause an uncontrolled release of energy and water downstream. For those of you that are operating under an MS4 stormwater permit, excuse me, in order to get the credit for your facilities, they have to be in proper operational condition if they're working. And again, this is only applicable if you are an MS4 permittee. Liability. Facility owners can be directly liable for any damage or injury resulting from a facility failure. Nobody can afford that. Nobody wants that on their conscience. So we're going to do everything we can to make sure that we're not the cause of any damage or injury or deaths downstream. And finally, but certainly not least important, is stewardship. Why are we all here? The mission is to protect the environment and reduce the impact on human activity on the watershed. Most of us, I hope, got into this water quality business because we've got an interest in maintaining a quality environment and a quality watershed. So, dam failures are bad. As I mentioned, loss of life, loss of property, damage to property. On the left here, we've got a picture of a roadway and it looks like a small precast concrete bridge that was below a failed embankment with an uncontrolled release of water. And as you can see, it pretty well destroyed the roadway and caused quite a bit of erosion. On the right-hand side, we can see a series of picnic tables in the downstream channel that were picked up and carried downstream in this release. This did not occur when there was anybody in attendance, but boy, just imagine if this had been full of 4th of July picnickers and merrymakers, et cetera, et cetera. Not good. This is absolutely what we must avoid. So, to avoid problems, we need to inspect our facilities. Now, planning and inspection. Personally, I like to review every piece of data I can get my hands on. If you're a municipality or jurisdiction, you probably have a file or a folder on all of your facilities. Let's hope so. And in that file or folder should be all the history of the facility, starting with the construction documents and the as-built package and plans. I like to review them if they're available. If there are any changes or any conditions were encountered during construction that required a change to the design or a change to the layout or the means and methods, that should all be documented in the as-built package. So that's where I like to start. Any additional data I can get my hands on, prior inspection reports that are in the file. Personally, when I'm doing an inspection and I've got a set of paper plans in my hands, I make a lot of notes on them for the next inspector to use. Google Earth has a provision where you can find a site, look at it from the overhead view, and go back in time. There's a timeline feature at the top. Again, it's interesting. I find interesting and helpful to see how the facility has, for lack of a better word, evolved over time. Site contacts. Some of these facilities are going to be out in the public where you can just walk up to them. Some of them may be on private property. Some of them may be in an industrial facility behind a fence where you need an escort to go there. Reach out to your site contacts, make your appointment, make sure they know you're coming. And if they need to meet you there or give you access, get that set up. And I'm going to briefly just jump to the next slide to talk about the field kit, because this is pretty straightforward stuff. Your PPE, everybody's got to have their personal protective gear. I'm not going to speak to the conditions that we're currently operating under as far as COVID, but everybody's got their own SOP for dealing with that at the moment. But yeah, I've got my hard hat, I've got my vest, a digital camera, probably one of the most important tools that you can carry with you. I also, when I take digital pictures, and you can't take too many, trust me, I like to set up the date stamp so that it's visible on the image, so that it's visible in any report or any other documentation that you turn in. I've got a clipboard here for notes. My notebook fits right in my back pocket, a tape measure, my credentials, a screwdriver, which is handy for probing the bottom of metal pipes, and there's also a pair of boots back there. Again, this is the very basic kit. This is so you can do a quick visual inspection. Again, these inspections could get quite invasive. We're not going to go that far today. We're going to hit the high points. Anything that needs to be followed up on will be documented in your report. So let's go to the site. All right, here we are. I like to start with an overview. Just stand back and look at the facility if possible. Just take it all in. The one on the left looks like a pretty well-maintained facility. We've got a nice embankment with turf on it, a nice control structure there. Everything looks like a golf course almost. Probably not going to have any problems inspecting that facility. The one on the right is a little bit of a different story. This thing is completely overgrown. It's very likely that the fence won't, the gate won't even open because of all the vines and other growth that have intertwined with it. Depending on what your policy is, you may walk away from this one and not even start the inspection until the facility has been cleared. Again, this is the way. This is dependent on how your particular system and protocols are set up. But the fact of the matter is, if you can't see what you need to see, you can't inspect it. So, the plan of attack. Over the years, I've learned that consistency in your approach is very helpful. I like to start, and many other people that do these inspections like to start downstream and work upstream. So what we've got here is a list of items to hit in the order to hit them. Now, understand, if you happen to walk by an inflow on your way to the outfall, feel free to make a note of it. You don't have to follow this strictly, but it is a flow. So number one, we've got the principal spillway outlet. And again, we're looking at not only the outlet, the end section, but we're also looking downstream to see what's happening in the receiving property area. The downstream embankment face. Again, number two, we're going to check the entire downstream embankment face for issues. And I'm going to get into the issues that we're going to look for as we move forward. The embankment crest, top of the dam, control structure and outlet works. Again, this could be a metal structure, a concrete structure, could be a weir wall. Again, we'll deal with that when we get to it. The upstream embankment face. The basin interior or main bay, if it has forebays or pretreatment. The forebays and pretreatment we're going to look at. The inflow points, and finally the emergency spillway. And just a little piece of history, I actually worked on this particular pond when it was constructed. It has to have been over 20 years ago at this point. So starting at the outfall and points beyond. This example, we've got a corrugated metal pipe principal spillway with a flared end section. Other than the trees being pretty close to it, it looks okay from this vantage point. But if we look downstream, what do we see? pretty significant erosion head cutting here in the left-hand photograph. In the right-hand photograph, looking back upstream, we can see the armor at the outfall has been swept away. The filter cloth is hanging, and this cut is probably 6 feet or better. Document it, take your pictures, get it into your report. We can follow up later on why it's happening. The important thing for this exercise is to document that it is happening. How about the principal spillway? This is a corrugated metal spillway. The one on the left, it looks pretty good. It's got some surface rust in the bottom. This is a situation where I would probably probe that with my screwdriver to make sure that the metal is still intact and solid. The one on the right, well, it speaks for itself. The entire bottom of that principal spillway has rusted away. Water is now free to carry away embankment material, and we have a perfect situation set up here for piping and a potential failure of the embankment. Again, it's pretty clear what the solution here is. The pipe needs to be replaced, but we'll speak to that a little further along. Concrete spillways can have issues too. Something is blocking this spillway or is restricting it at this pipe joint. Again, in the course of this inspection, we're not going to crawl up in the pipe and see what it is, but we're going to document this. We're going to note it in our report, and it needs to be followed up on. Moving along, what are we looking for? A quick list. As noted, the condition of the spillway invert. What kind of shape is it in? Again, these corrugated metal pipes, folks, that have been going in 20 to 25 years, maybe 30 at the outside is their expected service life. They're going to start failing, and I certainly did quite a bit of work fixing these in my previous lifetime. Joints, pipe joints. Are we getting soil coming in? Are we getting roots coming in? Are the joints lined up, or have they shifted and displaced? Again, if you've got soil coming in, you may very well have a displacement at the joint. Egging of metal and plastic pipe, and I've got two symbols here on the right. One of them is lovely round, just like the pipe is supposed to be, but the one to the right, you can see, has what we call egged. This typically is found in corrugated metal pipes, especially larger ones. Once we get up above 36 inches, 48 inches and up, if the contractor gets his heavy equipment too close to the facility, or if the way he places his backfill is not done in a conscientious and careful manner, we can displace that pipe, and it can be bent out of shape, literally bent out of shape. That's a problem. It needs to be documented. Misalignment. We noticed in Charlie's presentation, as he was looking up from the downstream end of a principal spillway, had a nice full moon at the far end. That tells me the pipe is straight. But if I'm not seeing a nice round daylight at the far end, I've got this crescent moon here, as I describe it, the pipe is not straight anymore. Again, it may or may not be a problem. It needs to be documented. It needs to go in your report. Foreign objects and obstructions, like we saw in the previous photo in the concrete spillway. Again, document it, get it into your report. Evidence of piping. And Charlie talked about piping a little bit, but again, this is a situation where the water is actually traveling along the exterior of the spillway pipe rather than inside it. And piping is a serious problem because it will carry soils and other materials away from the interior of the embankment and cause it to become structurally unsound. Evidence beyond evidence of water flow, if you've got the presence of wet soils or mud or anything else at the downstream end of the principal spillway, again, that's evidence that potentially piping is going on. Document it, photograph it, put it in your report. We'll follow up on it later. And if there is a head wall at the spillway, again, Charlie talked about this a little bit. There should be some drain outlets in that for the filter diaphragm. Document the flow if there is any. And as Charlie said, are we losing soil? If we're losing soil and we've got water flow in these drains, we've got a problem. It needs to be documented, needs to be called out, and it needs to be followed up with. So here's a photo of a head wall with drains. This particular example is still in sediment and erosion control mode, but the principle stands. We have two toe drains, one on the left, one on the right. The one on the left, it's got mud coming out of it. Again, it's a problem, it needs to be documented, it needs to be followed up on. If there was actual water flow, I like to get an idea of what the rate of flow is. This might be a guesstimate, or you might have a little measure that you can throw under it in time and see what the rate of flow is. The one on the right doesn't look too bad, but we're not sure. Again, we're going to follow up on this and see what's going on. Downstream embankment face. It has to be clear in order to properly inspect it. What we're looking for is animal burrows, erosion, slumping of the soils, wet areas or seepage, boils. That would be water bubbling up at the downstream face, maybe carrying sand or other material with it. Woody growth and bare soil, just to name a few. And again, if we look to the left, I can't see effectively if there's any wet spots or if there are any groundhog holes or any other issues. That embankment needs to be mowed before I can do a proper inspection on it. The one on the right's looking pretty good. It's turf. This is off season, so it's semi-dormant. Now, certainly we would want to pay attention to this green spot here. That little green spot may be evidence of some water getting through the embankment. Again, just looking at the photo, we're not sure. If I was there in person, I would probably step on that and see if it was wet. But again, document it, note it in your report. The next inspector is going to want to follow up on it. As far as the trees at the toe of this embankment, again, we could run down there and measure that, document it, get it in your report. It may require some maintenance and clearing down the road. Slumping and erosion on downstream face of embankment. These are pretty significant examples. They may not always be quite so obvious. On the left, again, we've got obvious cracks opening up in the embankment as it slides down the hill. And on the right, we've got all kinds of things going on. We've got trees on the embankment. We've got slumping or settling around the spillway pipe. This may be due to piping. It may be due to poor backfill. We don't know. We need to document that there's a problem. We need to follow up on it. Woody growth. We've had a lot of chat about woody growth today so far. The regulations are very clear. The dam owner must maintain all areas of the dam free of trees and woody vegetation. This includes 15 feet within the upstream and downstream toe of the embankment, within a 25-foot radius of the control structure, and within 15 feet of any abutment contacts, outlet, spillway area, and plunge pool. And there's also some additional language here I'm not going to get into specifically that deals with the emergency auxiliary spillway channels. Again, the point is they can't be restricted. They can't have woody vegetation in them. The facility needs to be able to perform as designed. If you find any of this, even if you're not sure if it's kosher or not, document it. Take your pictures, write it down. Everything can be followed up on. Looking at the embankment crest and upstream face. Again, we're looking for slumping, animal activity or burrows, sinkholes, whirlpools, woody vegetation, bare soil, eroded areas, backwater into the inflow pipes. Backwater is an interesting question. This is where a review of the plans is helpful. Some facilities are designed that they are intended to have backwater into the inflow pipes. I'm not an engineer myself. I don't necessarily know what would drive a design like that, but I have seen it and it has been shown on the design plans. So again, that's something that would normally be a flag, but it may be okay. Again, we have to know what the design intent was. On the left here, we're not sure what's happening here either. This could be an old animal burrow that's collapsed. It could be just a slump or an eroded area. We don't know. We're going to photograph it. We're going to document it. It's going to go into our report for follow-up. On the right, we've got a weir wall. We talked about weir walls as control structures. It's a pretty big one. It's probably about 40 to 50 feet across. You can see at the top, we've got two groundhog holes up there. The groundhogs not only provide a conduit if water probably can't get that high, but if it did, it would certainly get into the embankment, weaken the embankment, could potentially come out the other side of the embankment, depending on how far the burrows extend. The burrows have also generated a lot of overburden from the groundhog's excavation work, which can potentially clog up or compromise any low flow apparatus that we have in this facility. Again, document it, get it in the report. We'll follow up on it if need be. and determine what the best course of action is. Control structures, quite a variety here. Top left, we've got the classic corrugated metal mushroom that we're all so familiar with. At the top right, a very, I don't want to say primitive, but let's say a very basic weir wall with a low flow orifice. Something to note here, this fence has metal mesh behind it. It's not just a wooden fence. It's got a metal chicken wire backstop to it. This is potentially a problem. If, again, this is a very low weir wall, but should this get a high flow event and debris get carried down here, it's not going to be able to pass over the top of the wall. It's going to get caught in that chicken wire. This is not a good idea. It may be on the original design plans, but again, as an inspector, flag it, make a note of it. It may need to be removed. It may be decided that it will be removed, but let's make sure that everyone involved knows that it's a potential problem in the field. Lower left, this control structure is basically a combination of a concrete spillway and a tiny little weir wall. It should be clear. The little tiny low flow orifice should be clear. There's other sediment built up here. Document it, make a note of it, put it in the report. On the right-hand side, lower right, the classic concrete control structure with a metal trash rack on the top. And one thing to note here, it may not be very visible in the picture, but there is woody material sitting on the ledge, which tells us that at some point this facility filled up with water to the point where it was going over the crest. That may be a clue to investigate the low flow and make sure the low flow is open and operating as designed. So as far as control structures, we're looking for structural integrity, rust, leaking joints, spalled concrete, cracking. Is it plumb? Has it settled? Boy, if a control structure starts to rotate or settle, all the joints are going to open up. It's going to be very problematic. If they have manhole covers, there seems to be sometimes they tend to disappear. Are they there? Are they supposed to be there? Make sure they're there. Document them if they're not. Hydraulic function, is the low flow clear? The weir openings clear? If there are dewatering valves or drain valves, are they properly configured? More than a few ponds out there that were designed to be wet ponds, nobody ever closed the drain valve. They've never developed a permanent pool. Again, this is where your awareness of what the design intent and the design plans are comes into play. Valves need to be exercised. If they don't get exercised, they will stick, and when you need them, they won't work. So there should be some sort of record of exercise, and if not, maybe someone needs to start it. And lastly, is the interior clear? The interior, the control structure can collect debris. Debris can also be placed there by our industrious friends, the beavers. They love to stash food in any underground or a box structure if they've moved into the area. And again, this will totally compromise the hydraulic performance of your facility, and we could end up with all sorts of bad things happening, the worst of which could potentially be an uncontrolled overtopping of the embankment. External factors, we talked about woody growth within 20 feet of the control structure, animal burrows, erosion, piping, vegetation, all problems, all need to be documented and put into your report. Same thing with trash racks, if it has one. Is it present? Is it supposed to have one if there's not one there? Is it secure? Is it sound, not rusty or deteriorated? And is it clear? Again, we're looking at hydraulic performance here. We need these things unrestricted so the water can get in and out as the engineer intended. Just two quick shots here of concrete spalling. This on the left is a slab, a garage slab. And again, you can see the finished surface here, but it is flaked off and exposed the aggregate and the unfinished surface underneath. Same thing on the right. This is a concrete lintel under a window in a block building. The corner of it has flaked off or cracked off, again, exposing the aggregate underneath. Again, just for folks who might not be aware of what spalling is, these are two quick examples. As far as issues in the control structure, top left, we've got a corrugated metal pipe joined to a concrete structure. There's a gap right there in the joint. There's a gap on the other side in the joint. It's a classic setup to introduce a piping situation. If this control structure starts filling up, water is going to run along the outside of the pipe rather than the inside. And that's going to compromise the pipe itself as well as the embankment. Needs to be documented, probably need to have a repair order issued on it. Top right, we've got a volunteer tree starting to grow against the control structure. When this tree dies, it will leave a void. The roots will leave voids. Potentially, water could get in those voids and undermine the structure, or the structure could simply settle as the support underneath of it deteriorates. Lower left, this is a control structure that is completely surrounded by vegetation. Again, the critical problem here is this will clog in a high flow event. The last thing we need when we get one of our coastal hurricanes or nor'easters that delivers a lot of rain is this control structure weir to not be able to let the water out. Again, it's got to go somewhere, and if it can't go through the control structure, the principal spill or the emergency spillway could be overwhelmed if one exists as part of the design, and we could have an overtopping event. Again, document it. There's maintenance to be done here. Lower right, this is a low flow orifice inside a control structure. Again, you can see it is semi-clogged. This is something to be documented. Again, there needs to be maintenance performed here to get this clear and operating properly. Two more quick examples.
Sorry to interject. We have about 4 minutes left.
Okay, I'm just about done, guys. We've got some low issues here. Don't know what it is. Could be a burrow, could be a sinkhole. At the right, we've got a low flow clogged with an Elmo dowel. This is absolutely legitimate. We found this in the course of an inspection. So that facility is not going to dewater properly. Basin interior, very quickly. The interior, we're looking for trash. We got a jet ski. We've got tires. This growth may or may not be appropriate. We need to know that based on the plans. Lower left, we've got a sinkhole. Lower right, we've got a pond that probably is holding more water than it should. Again, this goes back to what's the design intent and what do you see during your overview? Document it. Very quickly, since I'm short on time, I'm not going to run through these. I'm going to jump to the next slide. Forebays, this is about going to wrap it up. Forebays, pre-treatment and inflows. If we have sediment deposition at an inflow, that needs to be documented, needs to be looked into. There may be a problem upstream. If we've got excessive vegetation or other issues in a forebay, again, needs to be documented, needs to be cleaned out. Lower left, standing water. If it hasn't rained for a few days and your forebays are holding water, there's a problem. Needs to be documented, needs to be followed up on. Standing water in the lower right, again, this is another opportunity to look for illicit discharges. Do you have dry weather flow? Is it dewatering properly? Have you collected a lot of trash and pollution? Again, you can't take too many pictures. It all goes into the report. And we just talked about this. Again, hydraulic performance. Are they dewatering? Is there no short circuiting around berms or weir walls? Sediment levels, trash, evidence of illicit discharge or upstream problems, structural, are the berms intact? Do we have groundhogs or beavers? Monitoring wells are not broken off. Here's two forebays with bad issues. The one on the left is restricted and clogged up. The one on the right, not only is it eroding, it's about to fall off the end of the pipe. And this staining indicates we've got something unhappy occurring upstream that should be followed up on. Document it, get it into the report. Final thoughts, safety. Safety is priority one. Safety for the public, for the property owners, for the downstream habitat, and the inspector. Your jurisdiction should be getting you the safety training you need for the level inspections that you're going to be doing. As I said before, we're limited in scope due to time. Structural issues were the main factor today. I could probably speak for 3 or 4 hours on inspecting facilities without any problem and still be short on time. Please reach out to me or anyone at MDE. If you have questions, discussion on maintenance performance inspections on any kind of BMP, not just basins. We're working on some guidance documents for you guys. They're in development. They're coming. That's all I'm going to say about that. So they're coming. And as always, tell us what you need. What are you looking for? What are your training needs as far as field inspections and reporting? And with that, boom. Questions? Do we have time?
About 1 or 2 minutes for questions, definitely.
Okay, Pat, and a quick question. For mowing of slopes, isn't vegetation considered a stabilizing mechanism against erosion of slopes? Why is mowing preferable to allowing roots to take hold?
Well, in the case of woody vegetation, the more roots that you get into the structural embankment, and I'm talking about the embankment that has been built to a specific set of construction standards, when that material dies, when that vegetation dies, those roots will decompose. The tree trunk, if there's a tree trunk, it will decompose and it will leave voids. And over time, this will continue to basically chip away or erode, if that's the right concept, the integrity of the embankment. Um, and you need to be able to see what's happening. So we would encourage a robust growth of turf, but beyond that, it really limits our ability to see what's happening and to keep control of the structure.
Okay. And how should trees be removed from a dam? Should all trees be removed? Does it depend on a certain diameter?
That's an outstanding question, and it has a lot of answers. And I'm going to defer. I don't mean to shed it, but it's farther than we can get into here. I'm going to defer to Mr. Roach and Mr. Wallace from the Dam Safety Shop. I believe they have generated very specific guidance on that very topic that is available to anyone who would want it.
That's right, Pat. On our dam safety website, under the policies and guidance, I think it might be policy number 1, in fact, that talks about expectations for tree removal. And remember that small trees become big trees. So everything goes.
That's it. That's absolutely right. Again, and a small tree that doesn't seem like a problem today can be a significant problem tomorrow.
All right, and that's it for questions.
Very good. Thank you, everybody, for your time. Really appreciate you coming to the show. And again, please reach out to me. There's so much more material to be discussed in this area. We just don't have the time to get into it right now. So it's near and dear to my heart, and I love it. So there are no bad questions. I'll entertain them all.